I'm streaming. I'll put the timer for 1 hour and a half. Not sure if I'm gonna stay more or not, but usually it's a good time to take a break after that. And I'm gonna put some music on the background, I think, and continue to do the poker thing that I was doing. I think I figured out, I'm pretty confident that I figured out what the problem was. But it's one of those things where there can always be something that I missed, so. And I guess a good thing for this would be to do tests, but I don't think it's worth doing now, because there are so many other things that I need to do, so just wanna do the actual stuff that is gonna give me results first, then worry about the other stuff later. Because it took a bunch of time, I think I figured out what the problem was, which was the data. Some of the hands where either one of the players sits out of the hand, then the pocket cards don't work. And there were some situations like that. So I made some condition here. The other thing that I figured out just right after I stopped streaming is that I was putting the ID on the wrong place here because I forgot that I'm looping through the files as well. And that's why the IDs were messed up there. It was reinitializing them after each file, so. And this ID system here, I didn't think about this on the previous time, but it's a really good idea to debug these lines here. Because then based on the ID, I could just print the lines for the hand. And that helped me a lot to understand what was going on there. So the other thing that I did was I think it was on the pre-flop part. I put one condition here and make the player fold if that's the situation. But after this, I also saw that there was a lot of other places where it wasn't necessarily like this, it was other patterns, so I decided to just skip here the places that it was like that. So I just created a different variable here, and if there are no cards, I just skip, because that's easier. I skip the hand, because the main problem I had with doing this, the main concern I had is the whole thing about what if everything else is wrong. So after I made sure that it was the data and it was that thing, and like there is a very low chance that this is wrong, the code, the data, and the way that everything is structured, then I decided to do the other thing, because now I feel confident that everything else is correct and I am getting the correct data for each player. So here I think I think I don't have enough data yet to have a decent representation of the way that people play. But I'm obviously gonna continue to build, because then once I have everything set up, I can just play a bunch of hands and so have enough data. But I think I'm not gonna upscale here. I was doing this because I had a lot less data on the other ones because it was just river cards, but now here I think that I'm first gonna do it like this, and then after I have a bunch of hands, if I decide that it makes sense, I will upscale so that the frequency is higher but the overall distribution is the same in the beginning. Oh, here I messed up as well. It's current there. Attributes, the directory stuff. So I think I'm gonna run this again and save all the files again for the ranges, and then I'm gonna create a script to get the flop frequencies, which are not gonna be difficult. As it looks like it's working. Or maybe I'm not saving for a hero. Oh, it's because of the name. I have to pass the name here. Maybe I should do just hard code the names. Whatever, we'll leave it like this for now. It's not that big of a deal. Later on I'll figure out. So what else do I need? I think I need the board, and then after the board I'll start working on this thing here. This one is gonna be difficult because I think I'm gonna create a file just to test if everything works. Because I'm gonna have to test each function at a time to understand how to build the tree. I think this function is fine to add nodes. The more complicated stuff is gonna be on the tree class. I was thinking about something that I had to change here as well. Current action. Oh yeah, it's for the turn. So for the turn, I think the current action is gonna be a card. Or for the river. Because I want to have a node there so that so I can traverse obviously, but the value is gonna be a card and not a number, I think. So there's two questions. One is how I put the bats here, how should I put the bats? And the other question is, yeah, if I should do numbers or not for the bats, and then because I'm gonna have to check for this here. I'm thinking about putting the nodes as the cards, on the cards as nodes in children, and then the current action is gonna be the card, and then that's gonna be the difference between that kind of node and the other node, and then I can use this condition here. So I have to check if it's a string or a number. That would be good, but then it depends on the way that I'm gonna put the bats here because of the node ID. In the node ID, they require you to put the B before the bat. So if I do like that, it's gonna be a string as well, so I won't be able to check. Yes. Let me organize my thoughts to try to think about what should I do here now. So I have the preflop ranges. I think the boards now is the highest priority, then I'll figure this other stuff out. It's gonna be very similar to this one. Yeah, so it should be super simple, I think. I think I just need the flops, not the... So it's always gonna be the first thing on the boards. Board cards. Oh, because I have to loop through the hands. Yeah, so it's always gonna be the first, so... I'm thinking whether or not I should probably save this. Maybe I should save into JSON. So... Phone collections, parts counter. Yeah, they should get the frequency of all of them. And then I will put... I'll put them on a JSON file, I think. Because I'm gonna have to use that to filter the hands based on the board. And I think I'm gonna do that on the other, once I'm building the simulation. I could just load and then check to see if the hands exist, if the board exists on the counter. This images. So it's probably an error with the slice, or if there is no, yeah. So it's probably when there is no board. Okay, so let's print. Maybe if I do pop. I don't know why it's not working with the 0 here as the index. I think I have to make it equal to something. Oh, I'm doing the wrong thing, man. Now it should work. Yeah, there we go. So now I can upload this counter. Yeah, boards, data. No, this is Bulldog, board frequencies. I'll put this on here. I had this problem with the Git. I made a repository for this. And I had this problem where I accidentally uploaded to... I made a Git commit to the files that had the data. And they are too big to send. So I still have to fix this, which is figuring out how to revert the changes that I made to the commit, but it's really annoying. Like, I looked it up a bunch of times, not a bunch of times, but then like I tried the commands and it doesn't work. And I don't want to bother with this stuff right now. Maybe I will fix later, or maybe I'll just delete the thing and do it again, to be honest. Because it's not a hard thing to do, but it's just annoying and it's not necessary now, so it's not related to what I'm trying to do here. Obviously it would be important if I was working for other people, but yeah. It's not that difficult to figure out. Maybe I should sort this and... And maybe it's the data here. That I don't have enough, but it's kind of weird that all of them... Oh no, this one have... True. So, maybe I'm missing something. I'll copy this here. Ah, fuck. Yeah, obviously can upload there. It's kind of weird that... So I think I'm gonna sort this stuff. Let's just sort, it's kind of annoying. I'm just gonna look it up. I'm gonna use ChatGPT for this. You have to use sorted and then the key as an argument. Something like that, and lambda, and then... But that is not that good, I think. Let's see if I could do it a different way. I could just make a dictionary as well, instead of making the counter. I think I'm gonna do that. Because it transforms it into a list. I think I'm gonna get it from the other file. Where is this thing? Oh yeah, just use dict. Oh, I have to put items here. Yeah, there we go. Okay, so now I can load this, and so let me create a different file. But what I'm gonna do now? So now I have the bars, I have the ranges. Now I build the simulation, but the thing is that there's two. I'm gonna build another file just to build the functions separately to test the functions. But there are two different things, I think. One is creating the tree with template batch sizes, and then the other is to populate the tree with the custom sizes. So there's two different parts. And on the custom sizes part, then I can decide whether or not I just approximate or reduce to the standard batch sizes. So I think what I should do again is to get the standard batch sizes again. And they have to be on that format where each player is gonna have the actions. That's another thing that I have to see here. Yeah, I just put the actions here. I didn't separate by raise or bats. And this is the thing that I was struggling to think on the beginning. Struggling to find a way whether or not to, because you need both the sequence and the bats. And so here I have to create something that classifies whether or not it's a raise or call. A call or a check doesn't matter because I'm uploading them as strings, I think. So I need to differentiate between call, raise, or bat. That's the problem. I wanted to avoid doing that when creating the data because then it gets too complicated. There's too many nested things. But in order to populate the tree, I need the sizes for each one, and for the size I need the classification. So thinking about how I'm gonna, because I can use the node ID to get the frequency, and then I can use the actions of each player to get the whether or not it's a raise. Raise a bat or a call. So let me think. Because I think I need to both loop through the node ID, and then from the node ID look at the actions as well for each player in the hand. I'm trying to think how to connect these two here, these actions with this node ID. I think I'm putting 0 if it's a check, or a call, I put 0. Then for the bats and raises, I can use the simulations thing there that I did. You just loop over in the reverse and check for the value if it's greater, lower, or equal, to classify them as bats, raises. I'm just trying to think if there's another way that is easier, or if I don't need to do this at all. think. Maybe I should create the tree first, I think. Like use the whatever standard sizes I have there now, and then just create the tree of those. Is for the tree, after I have the standard bat sizes and I create the tree, then I think that it's just a matter of going through the data and figuring out the logic for the node ID to add the bats. And the annoying thing is the sizes though. That's the annoying part. And then figure out this add line is gonna be later, I think. But the add line, no, the add line I think is on the chips amount based on the percentage. So for the data, I think it doesn't matter that much. But that's what I'm trying to figure out here. Oh, the problem is that I'm changing the values here. Forgot about that. So I have to multiply by 100 each value. Yeah, that's the other thing. Multiply each value by 100. But then I'm solving it. It's gonna take a long time, but I'm gonna solve this to see if this, to make sure that the values of the tree here are it's gonna be the same values that I have here. Because that way I don't need to. I think that's what's gonna happen, and I don't need to translate into percentages. The only part where you need to translate into percentages is to create the standard templates, standard sizes. But even that I think is not necessary, because I'm gonna be creating the tree from here anyway. So I'm gonna use the actual values instead of percentages. Yeah, and I think that on Pio they also allow you to put the bats in chips. The only thing I have to do is put C here, and then it's gonna understand. So I think the whole percentage thing I can just ignore. So the only thing I have to remember is the starting pot, the effective stack. Yeah, the pot's also complicated, because I'm gonna have to change the size of the pot, each part of the node. You just add the bats. So it's not, shouldn't be that hard. The hard part is the line. Because after each bat, it increases here. This is a call. Yeah, so you take the highest value of whatever bats in the previous round. But then how I'm gonna do that for each node? That's the problem. So I think the condition has to come when you hit the cards. It's all about the current action here, and when is, so maybe it should be none here instead of 0, because it's gonna be a card eventually. So I think inside of the node here I have to put a condition that checks to see if the card is maybe I don't put default value. Actually it's probably better, because it's gonna be required. And then it has to go here. Transaction. Because these numbers here change, that's the problem. There is always a bat, it's always B, but then it changes the size. So in this situation, then the parent node would be the turn node, and in this situation here where is a call, then the parent is this value, and so the actual value of the current node is always going to be, so maybe I don't need the current action, because it's always going to be the last number of the node ID. Yeah, I think I don't need this actually. So, but I do need to figure out a way to yeah, because I need to create the ranges based on the children. And the children are the actions. And so instead of doing like this, I can keep like this, but I can make it so that it's just the less. But that's the thing, because it all depends on the format that I'm going to use. Because I can obviously do self.nodes and then get the last element, and that should come after. Okay. But then this is gonna return me the... Oh, and this is not gonna be... I'm gonna have to split this. And then I get the last element. But then that's the thing. Because then sometimes it's gonna be a string, and sometimes it's gonna be the B for 4. But I think it doesn't matter, because then the strategy ranges is just going to be the strings there with the sizes. So I think what I have to do is translate this format here into the bets here into the way that they are there. Maybe I should do that on the parsing script, but I didn't want to do that there because I thought that I might use the bats for other things as well, so it might be better to leave them as an actual number. Yeah, so here I have to separate by streets, and I do that based on the cards, I think. I think I can do based on the suits. I created a string of the suits, and if any of the letters for the suits are on the node ID, then I split. So I think I'll do the parsing first, the creating the... I'm gonna call this file creates tree. Just leave like this for now. And then here I'm gonna create a different class. So I'm gonna have to think about what do I need here. So the node I did is gonna be the flop. Current range is the pre-flop range, I think. It depends actually on the player, so let me think. Because the player that is gonna act first is always gonna be the out of position player. So the roots should always be the out of position. So and this should accept flop. So the range should be the range from the out of position for the roots. Position pre-flop range. Trying to think how I'm gonna do this with the other script. So I need to know the positions. The hands I'm gonna filter for the board, and then I can do the same logic that I did on the other one for getting the pre-flop ranges. In the beginning here, I do the same thing. And then I get all the information. Oh, I also need the starting pots. Starting pots. So let me think. Current range, current node ID. The node ID should be easy as well. And just get up to the flop. So now on the main one, I'm gonna filter by boards first. If the board is not on the dictionary, then I continue. And then after I do that, then I loop through the players, get the information from the players that are on the hand. Then get their positions. Maybe I should set up which player it is here. Set up the names of the players. I'm trying to think if that's gonna be useful or not for building the thing. I think the positions are necessary, but maybe the positions are only necessary because of the ranges. Yeah, I'm gonna have I'm gonna need the true starting pre-flop ranges. I'm gonna leave like this, so and then just add this thing to the dictionary. Because the thing is, even though the outer position is not the first node, it's gonna be the second node, and then all of the other ranges are a byproduct of the beginning ones. So I think I need the two beginning ranges here. And then I'm gonna have to construct the other ranges. Yeah, but then the other ranges are gonna be different nodes, I think. Like the root node is only gonna contain the... Oh, I need to append the childs based on the actions of the flop. But that's gonna be a function. So I need to think about... Yeah, to start everything off, I think I just need the in position pre-flop range and then out of position pre-flop range, starting pots and starting node ID maybe. So I don't need the parent, I don't need the street. the invested is gonna be 0 for both. Let me copy all of this stuff from here. See what else do I need to put here. A current range is gonna be on a position pre-flop range. Current node ID. It's gonna be the starting node ID. Let's look at this. So range node ID. Starting pots. Yeah, the rest is all default values, I think. Streets has to be flop. I think I don't need to put this here. Yeah, I will only use the poker node for the poker tree, but then here I'll do it for the poker tree. Maybe I can filter first, but I think that's not very efficient, because then I'm gonna loop anyway. So I could create a filter for the data based on the thing, but not very efficient. Also, I should do the current thing here. It's more resilient, I think. So I get the current directory, remember the paths. And it's gonna be and then this is gonna be board frequencies. It puts hands here. Then I put if hands, board cards, nodding, board frequency. Obviously, there's gonna be all of them because I'm putting all of the. Well, it's gonna skip hands that don't have a board, but then all of the other ones is gonna run. But then I can just save a different one if I want to. I can just filter based on the frequency because it's sorted. I can do based on the index then. I can just cut the dictionary, I think, for whatever amount I want later, if it's too many. Because I think that the biggest issue is that it takes a long time to create simulations. And depending on what I want to do, I just want to get the bars that happen most often, because those are the ones that I'm going to have the most data. So, I don't know, continue. And then here, I'll do the same thing as I did here on the other one. Maybe we should put this on a function so that it doesn't become crowded here. And get player info, something like that. I think I'll leave it like this for now. So I need their position, their cards, what else? Oh, here I need the ranges as well. That's when it's gonna get complicated. So I can create another function and then just go over the directory there, just to look for the ranges. So I need this folder structure, and then I just look for the range based on the JSON file, then I open. So I'm gonna create a function that goes over the directory. I think I can use OS walk for that, and then I just do like the same format that I did, like a string format, to get the range from the JSON file based on the type. So I pass the type, and on the function I open the directory that has the type, and then I don't need to use OS walk, just look through the folder and find the range. So yeah, let me think. This is gonna happen after this thing here. Is there anything else that I need from the players? This stack? And do I need the cards? That's another. I think that... Maybe I don't need the stack. What I should be doing first is just getting everything, the things that happen most often, then creating a template. Yeah, that's the thing. Like, because if I put a different stack for each node, then it doesn't work, I think. Well, it does work, but it gets to... let me think. It's difficult because there's several different things that I can do. I'm not 100% sure on what to do first. One way to look at it is to create the... And that's why I need the bars though. It's because I don't want to create a tree for... That's the problem. I don't want to create a tree for each flop. Like, populating this way is not the best, I think, the way that I'm doing it here. Like, what I should do is loop through the boards instead. But I'm gonna have to loop twice anyway, because like for each board I want to get the data for the board based on all the data that I have, and then use that data to populate the actions. I think that's more efficient, because if I can do it like this also, but then the problem is that for each thing I'm gonna build a new poker tree. So I'm gonna have to put the condition that if the tree doesn't exist, I initialize one. But then I'm gonna have too many trees at once. It's not gonna be possible, I think, to do it. I think the way that I need to do it first, and that's why I wanted to do the boards first, is because then I can loop over the boards, and then from the boards I can loop over the data. And I don't think there's any way to do it faster than this, because you need to go over all of the data. Yeah, the issue here is that it's not efficient, because so there must be a faster way, because then like I'm going to waste a lot of time going through a bunch of data, like a lot of times, without building the tree. Oh, I remember now. So what I wanted to do is create the flop simulations first. Yeah, that's what I want to do. So I think I need to stop this one and then go do that. So I need to have the simulations first for all the bars that I have. That's what I need to do. So I need to get the bet sizes, I think. Maybe I create a data structure that associates the board with the bet sizes that are used, and then I store that instead of the board frequency. I can store the board frequency as well, but I think I'm gonna create another script, then make the board, and then the value of the board is gonna be the bets that are used. And then I have to figure out if it's a bet raise, if it's a bet, a raise or a call. And I think the way that I'm gonna do that is using the simulation there, the thing that I already did here. So maybe I should create a different file with this kind of functions here, and then use that on the other one. I think that's what I'm gonna do. I'll be right back. I'm back. So, like, I think there's two different ways. The problem is that I can't create all of the seams at once. That's the thing. I'm just trying to think about which way makes more sense to do it. The issue with the other way that I'm thinking about now is that, like, I'm gonna go over the boards, the flops, and then I create the simulate. Like, first I get the bat sizes that are used on each board most often, or all the bat sizes that are used on the sample, and then I build the simulation for each one, like a standard simulation from Pio, not from the tree that I'm building here. But the thing is, I'm gonna have to create the algorithm for adding the lines as well. So I'm gonna have to create the algorithm for adding the lines, and I'm gonna have to separate by the board type, the hand type. So if it's 3-bat, then obviously different than single spots. But the issue with that is that then it requires that I have a bunch of solutions, the standard solutions, and then I don't node lock them. And then the other way would be to make the solution and node lock the solution already. So that way, like, you're only saving the node lock solution. I think that way makes more sense, because then it doesn't require me to hold a bunch of different simulations that I'm never gonna use, because I'm only interested in the ones that have the node locked. They are node locked with the data. But then the question is how to create the simulation and node lock at the same time. So I think that in the first iteration, or the first part of the process, I think the first part is just getting the information. Like, go through the data and get all the information that is needed to create the tree. And then from that, create the tree. And the tree is the simulation. The issue is that it depends on the... Yeah, that's the thing that I don't know, because I think if I make dependent on each flop for the bats, if I add that information, then it requires too much data to build it. I think that's the problem, because I'm not gonna have like a lot of data, at least not in the beginning, for each flop, each bat on that specific flop. I think it's better to make the bats generic first, and then get the standard sizes that are used on all of the boards, and then loop over the boards and create the tree based on the board with the bat sizes. So, and the reason why this matters a lot is because then, like, if I do it like that, then Poker Tree is going to become more of a class that just creates the tree based on standard sizes, not get the sizes and update the tree with the sizes. Because then is a different thing, because like I'm not going to have the node ID for the specific hand. Or I can create another class or another function that searches inside of the class that searches for the tree based on the node ID. So once I created the trees, I can use this, like I can use this not only to create the standards, the sim of the node locked with the standard bat sizes, but then I can use to navigate based on the bats as well. So the first step of the process is to get the standard bat sizes and then create the tree based on the standard bat sizes. And then the second step would be to search for the simulations that I have saved that are not locked already for the sizes on the data. And that way is like I'm searching on the tree that I already created for the node ID that for specific node IDs. Because the question is how, like, that's the thing. I think because where does the node lock come from? It's just the difference in ranges. That's the thing that it is confusing, I think. Because if I build with the standard batch size, I'm gonna have the GTO solution for that, but it's not gonna have any node locks, I think. So the only way to do the node locks is to search for the actual decisions that were made and the solution that Pi got. So I think I can't get away with just... I think I need to have the solutions first and then go over the solutions. Like, there's no way to node lock as I build the simulations. As far as I can think. The only way to do that would be to get the specifics that happen on each hand. And so I need to solve from the flop first, and then because the whole non-locking thing. But that's the question. If I put, like, if I create the whole tree only with the batch sizes that are used, is that being node locked already? Like, in a way it is, in a way it isn't. Because in a way, like, when you build the sim from here, it's kind of like you're already node locking, because you're limiting the options of each player. So it's already a different hash than it would be if you have all possible sizes. But then in another way, it's not node locking because it depends on the actions of each thing. So the node locking that I'm thinking about is the actions one. And I think that depends on the poker node here, which depends on the ranges that are based on the children, the strategy ranges. But the question is how, because this can only be updated based on the data. Like, because it's not what actions did they take, but it's how frequently they took those actions. That's the challenging part. Because I think then I have to create a dictionary for each one. And that's what I need to save. So for each flop, each decision, there's a frequency based on all the possible decisions that can be made. And then based on that, you create the node locks. It gets really complicated. So the question is, can I do that as I do everything else? Or is it better to build the simulation first and then think about this? I think as I get the bats, but the problem is, unless I do a data structure that has the board as a dictionary, then the value is a dictionary again, and the key of the dictionary is the... But then you need to separate into another layer, which is the street, and another layer, which is the classification of the actions. Should be the either call, check, or bet amount. And then it gets really complicated because of the order of the thing. Because then I have to differentiate between call and check. I think the classification has to come from the node ID. The other thing I'm thinking about now is if it's worth it to go back and parse this in a different way, where I just put in the format that is here, or maybe just do, I think, yeah, maybe I can just do the string as well. instead of putting the bat, I multiply by 100, and then I put the on string format. Just on the node ID though. And so many things to think about. I think I would need to do this function here. I pass the node ID to this function. Let me think. I need to know which player did each action as well. Yeah, I need to know to separate them into the simulation. And I knew this was gonna be problematic because it's really hard to think about the best way to combine these actions here with the node ID, so that I have the... I think that's the reason why I left in this form. But the issue here is that it can be like if they bet the same size, but if they have the same size, then it is a call. Maybe I can do it like that. But then I have to check twice, I think. The issue is, how do you check? I guess I can look through the node ID and then I can check on each player if they have the action. And then if they both have it, then it's a call. But then who did the bets? That's the problem. Who did the bets? I think from the node ID doesn't matter, but it goes back to the thing that is confusing in my mind, which is what's the best way to do it. Because there's the way where I build the simulation first, and then there's a way where I try to node lock everything as I build. But I think that it's not possible to do it that way. Because there's too many simulations, so the way that it is possible is if I structure the data first and then create the simulations. But I have to like structure it in a way that it doesn't require me to build the tree each time. And that's the thing. So I don't use this on the first step. I just structure everything that I'm gonna need here. Maybe that's the way. Because the question is, if I have the ranges based on the data, am I node locking already? I think that if I use the ranges that I get from the data, then it's already node locking. Because the solution would be different if I solved from the flop. I think that's the thing here. Yeah, but this would require me to build the tree each time, I think. So I'm thinking about going over the data, and then based on the node ID, I create this tree here for the flop. And then I populate the tree with the actions that were taken. I update the range of each node based on the actions. Oh, that's the thing that I'm missing. So I need the pocket cards on this one. Because from the pocket cards, the problem is that there's position as well. That's super complicated. I think that this way, it would be the best way, but it's just not possible, I think. Where I go over the data and I update the ranges based on the data. Because there's too many positions and too many flops, so... Like on this script here, I would have to figure out a way to create a different poker tree for each time, for each different instance. And I think that's just not possible. It's not that it's not possible, but it just takes too much memory. So I think the best way is probably to create the simulations first from the flop with standard sizes, and then just update the ranges with the data. So I have to think about how I'm gonna update the ranges. Like I have to, this is what I need to create here, an algorithm that's either gonna be depth first search or breadth first search, or maybe it's like something else, but I have to think about that. And based on the hand, because the strategy range is gonna be the dictionary with the hands and the frequency that they're played. The thing is, yeah, it's the frequency of the action. So for each hand, I need to figure out what the action was, because that's gonna... Oh no, but that's already on the node, because it's dependent on the node ID. Yeah, so I need to loop over the node ID, and then as I loop over the node ID, I create the nodes here as childs. The first time I create the nodes, and the second time I update them. I update the strategies. Because all of the strategy ranges are going to be initialized to 0 at first. The frequency with the create range. And then for each hand that I get on the data, it's like I navigate through the node ID based on the actions, and I go updating the dictionary based on the hand, I think. So here I'm gonna have to maybe... I think it has to be inside of the node, the method, to update the strategy ranges. The tricky thing about this one is that it has to be a percentage, so... But I think... Yeah, so it has to be a percentage of the range here. Current range. But the current range depends on what part of the node it is as well. Because the current range of one node is going to be the strategy range of the other. So it breaks down like that. Yeah, so let's think from the beginning. It starts with the pre-flop range. Then I go over the ID and I add a node. And that's gonna be based on what actions I have there on the flop. And then based on that action, then I create the different strategies. Different ranges for the strategies. The problem, each time I add a child, I have to update the strategy ranges, I think. Yeah, maybe this is not the best design here, because... But I think I need to initialize here. Because at the beginning, the nodes won't have any children when they're initialized. So this is always going to be this, and it's never going to be here. So I think I need to update the strategy range inside of the addChild function. So each time I add a child to a node, I create this hand range. So I think I'm gonna do that, is better. Yeah, and this already is gonna have the action because I'm gonna create the node outside and pass here. So now let me continue to think. It's one of those things where it's just like in the beginning where like it's a decision that is hard to make. And even the decision in the beginning I did this way, but I'm not really sure if it's the best. Because it's really hard to come up with something that is simple and that is gonna allow me to have both of the informations of associating the bets with each player bets with the sequence of the bets of the current hand, because I need both of the... Not sure if I need, but it's good to have both of the information, I think. So here is very similar, but it's much more complicated because I have to think about how I'm gonna create each different range of each different action in the tree, and how I'm gonna update that with the data, and whether or not I create the tree from the flops first and then update them later, and that would be like no locking them. But the thing is, if I create them first, I have to load the sim and then I have to translate the ranges. I think it's more complicated that way. I think that it would be ideal if I could create the ranges with no locking them already. But the thing I'm not certain, I think that's how it works, because like if I update the ranges based on the data, then I think that's automatically no locking them, because it is like I'm putting the player's frequencies on the simulation. But the problem is that then I don't want to put my frequencies as well. That's the problem. Because then what would be solving for? I think I need to create the simulations first, and then from the simulations I navigate based on the tree and no lock them that way. Create the simulations. And then how would be the structure of this class here? You'd be just traversing the node IDs and updating the ranges. But you would have to update only one player ranges. That's the tricky thing. So I think the purpose of this class should be to update the ranges of a tree based on data. That's what it needs to do. But it has to be only for one player, I think. Because if you not lock both players, then I think it doesn't make sense. But maybe it does. It's gonna change the way that it plays either way. But no, it doesn't make sense because then everything's node lock. So I think I have to structure things in a different way, I think. Because I'm thinking about it in the wrong way. Like the way that I need to create these classes is more to like put a path that I want to navigate and node lock. And then, yeah, update only that path inside of the whole tree. And then not create the simulations from the flop, save the simulations from the flop. And then automate the process of node locking them. Based on the search of the nodes. So something that you would allow me to node lock every decision if I want, or only specific streets as well, or lines. But the question is, how would I use that to... Yeah, I have to look at the documentation. And... I would have to load the simulation first. Because I think the way that I thought about these classes here is building them in a way that I would create the tree directly from them. But I think that's not the best way. Because of the way that the data is formatted, and because there isn't, like, if you put each thing for a flop, then it gets really, we don't have a lot of data. That's a problem. And you have to create a bunch of different simulations. So to maximize the amount of data, I think it's better to create an overall template and then create simulations based on that, on the flop. And then from the simulations, node lock the issue is that you have to compromise as well on the bad sides, but I think you need to do that either way. Because either way, unless you can solve from the turn and the river as well, like programmatically solve, which it is possible to do. You just change the border. But the issue is that I think you need the whole tree to be able to node lock effectively. Or maybe not, actually. Like maybe you can have a theoretical amount, max amount of sizes. There would be all possible sizes that happen on the data, and then you just decrease based on some heuristic. There's so much stuff to think about. It's hard to organize, like to decide what stuff I'm gonna do first. That's the issue here. I think maybe the best way is to build the flops first. And then the reason why it changes a lot is because it's gonna change the whole purpose of the class, depending on which way you go about it. Obviously I can create another class in the future, but then it's a lot of work as well. So it's like, it would be better if I figure out the best way first, and then I don't have to think about this later. Just becomes everything automated. My biggest concern with creating the flops first is that the trees take a lot of memory to save them. So it's gonna significantly limit the amount, I think, of simulations you can build. And also for turning this into something later, then I think it becomes worse. I think it would be better to just create a node locked version first, but that's massively complicated. I think that's not possible as well. Like the only way to do that would be to structure the data and then create functions that have heuristics of what parts of the tree to automate the process of node locking. And I think it's not even possible unless you have a bunch of data to... Because if I filter by board, it's not gonna have a lot of actions for each board, I think. And because it depends on the position and the hand type as well. So I would have to have a massive amount of data to have the flops, to have a decent sample size that would be able to construct a range for each part of the game tree. That's the thing. So I think it's more effective if you have less data to build the simulations from the flop first. So first create something that gets all the most used bat sizes, which is the thing that I did here on the previous one. So get the most useful bat sizes, separate them into a data structure. Then from the data structure, you and from the template, then you create the simulations. And then from the simulations, you do this tree here. And the purpose of the tree is to search for the simulations. So I would have to load them and then search for the node ID. The problem is that I need to update anyway. That's the issue. I need to update the actions anyway. These things here, I'm still not 100% sure on how it works. I think it is from the most aggressive action, from the least aggressive one. The way that the set strategy is built. So it's a sequence of lines. And then each one of the lines is a range. Is the range for the path there. So it would be like setting the children. So it would be the lines with the set strategy for each action. The numbers of each combo should add to it. I think even though you need a lot of data, there's no other way. Actually not, if I build the other one, because if I build from the flop, it doesn't matter that you don't have a lot of data, because like the more data you have, the better, obviously, but then it allows you to update in a gradient. Because that way... So I think I need to create the tree in a way that it allows me to navigate through the pile solver solution. That's what I need to do. So first, yeah, I think that's the best way to do it actually. So I need to first get the simulation here. So build, and I'm probably gonna approximate the bet sizes, because otherwise it's gonna be too big anyway. So it's better to get the bet sizes first. But the issue with getting the bet sizes first is not I'm thinking about it in the future. Is not because it's an additional thing you have to do. So let's say, for example, that I only wanna run one executable and then it does everything. Like this thing would have to create another file that has the standard bet sizes and then uses the file to create the simulations, and then create the simulations, create the file or folder for simulations. And then based on that, then it does everything else. It no locks based on the data. But I think that's gonna be the way, because the other way is not possible. It's just gonna be... If I have to create a different tree for each one, it's just gonna be too much, I think. So it's probably better to create the standard bet sizes first, then create the simulation, automate the process of creating the simulations based on the standard bet size. So I will do the same folder structure that I did for the ranges, but the only difference is the levels there, where inside of the file there's gonna be simulations and not the position, the flops. But then I kinda do need, because yeah, the simulations are gonna contain the... No, because each flop can have different positions, so I do need to put the position name as well. So I need both the board and the positions, I think. But then I think I have to think more, because either one of these approaches I can do it, I think. Like I can see a path to do it. But the problem is thinking about what is going to be the most efficient way. That's the thing. They uses the data in the most efficient way as possible. They create the simulations that allow you to have the most significant impact based on the data. That's the challenging part, I think. So I would save on the same format here, but then with the additional information of the board. So it would have the positions as well, and then the board. On a different folder that contains the solutions. And then based on that, then create the everything else. I think I need to get the simulations, get the bats and create one simulation, and then from that simulation load the simulation here, and from that I see how to update that simulation with the locks. I should do it in one. I think I should do it first on only one sim, so to make it simple. And then from that, because that would allow me to create a template for updating and no locking a sim. I think that's the issue. I'm trying to think like too big first, like trying to construct everything first, and I think that's not the best approach. I think it's probably better if I just save one simulation and then I build like something that allows me to programmatically node lock a node. I think that would be already really helpful, I think. Because then you can node lock without node locking manually each one of the paths. So load the simulation and then traverse the tree and node lock based on the data. So I think that's what I'm gonna do. The first thing that I'm gonna do, then I think about all the other stuff. Otherwise I'm not gonna be able to do anything. I'm gonna get the boards that happen most often here, which is this one. I'm gonna get only one. And the problem is that I don't have enough data here. It only happens 3 times, so it's not gonna be enough to build anything. I need to play a lot more hands. But I can do an arbitrary node lock as well. I don't need to do it based on the data only. Yeah, so I get this board and then create one simulation for this board based on the standard bats. And then I create something that automates the process of node locking first. So loads the simulation. Yeah, I think that's what I'm gonna do. So I'm gonna forget about everything else and I'm just gonna focus on this. Programmatically node locking the nodes based on whatever, like an arbitrary random strategy. But I think I can still use the other classes that I built. Yeah, because I would use the class to populate the... But I think that's inefficient as well, if I have the tree. Yeah, what I have to do is load the tree and then I use show children as well, I think. Yeah, traversing the tree. So I can use this traversing the tree here functions, and then I'll set strategy on which one of them. Which would be similar to the stuff that I'm trying to do, I think. So if I do it just with the tree there, like if I create the whole tree with all of the ranges, then I can just do that here, where I navigate through this tree and then I grab the range from the other tree and set into this one. Yeah, so this is the current range, and this would be the strategy ranges. So the thing that I'm contemplating here is whether or not to use these classes to like load the tree and use these classes to update all the values of the solved solution, and then no lock based on that. Yeah, let me think. I think I'll have to do that. So load the tree. Load the tree from a file, then traverse the tree, like populate everything, and then no lock. Because otherwise, like how am I gonna change the frequency for each specific action? I think I have to recreate everything first. So I think I'm gonna do this on this file. So first I need the simulation, then I'm gonna load the simulation from here. And then from the simulation, I'm gonna create this tree here, I think. That's what I'm gonna do. Which is gonna traverse the nodes in the simulation and update the strategies based on that. And then once I have that, then I can think about how, because then it's just a matter of searching the tree. Searching each node based on a node ID. I think I can create a function here to do that. And then use depth first search or breadth first search. Which is gonna be hard to think about because I don't have a lot of experience programming with these algorithms. Yeah, but I think I can search based on the value of each node. The node ID of each node. So I navigate based on node ID, just like it is in Pio. And then for each one, I populate the ranges here based on the bats that exist here for the solution. So I'm gonna create something simple that gets all the bats first. Maybe I can use this one already that I built. I just use this one. And the only difference is I'm gonna use the actual values of the bats. I think I'm gonna do this offstring. I'm gonna copy this file here into the other one, and then I'm gonna remove the things that I don't need and change the things for the new format. And then this is gonna give me all of the bats that are used. And then I save them into a file, I think. I think I'm gonna limit to two bats on the flop, and then 3 on here, and then 2 raises and 1 donk. Something like that, or even less, because of the memory. So let me think. And then once I have that, then I create a simulation, or I create a couple of simulations based on the boards that happen most often. And so I'm gonna create another thing that loops through the boards based on the file there, this file, up to a certain amount, maybe 10 boards, and then that creates the simulations with the bats. And then from the simulations, I'm gonna go back to this file, and then I think I'm gonna just focus on creating something that loads the tree from Pio, and then populates these ones with the tree from Pio. And then once I do that, then I think I can think about updating the tree based on the data. And the thing is that it changes the thing that I'm doing though. So I'm not really sure if it's good or not. Because then it's gonna change the purpose of the class, because it's gonna require me to load the sim first for each one, which I'm not sure if it's good or not. But I think the algorithms are the same probably, so I can just remove the... Yeah, I can use the simulation to create the algorithms. I think that's better. And then once I have the algorithms, then I remove the simulation. I could just update the nodes with the algorithms that are created, because I know that it's gonna work on the actual simulations. Yeah, so I need to do a testing one first, where I just do from one simulation and then create everything from one simulation, and then I node lock that simulation and save the node lock, and then I compare the old version with the saved one. That's much better, I think, to do this way. Then once I have that, then I know that I can just upload. The only thing then it will require me to have the... But I can create other classes for that in the future. I think I'm gonna do this stuff off stream, and I have to think about more as well to clarify everything on my mind. What's the best way? So probably gonna come back tomorrow or someday after that.